So the first thing we're going to talk about is some properties. You will need to be able to identify these properties for the quiz. So just make sure that you can understand those properties for the quiz. Sorry, one second. Are any of these properties things that you feel like you recognize? We use them all a lot, but some of them I think are more common than others where we actually call them their properties. Any of them look familiar at all? Which ones look familiar to you? I think the distributive is usually the one that we name the most, like we actually use the name on it when we do it. Remember, it's when you have a number in front of the parentheses right that, and you're multiplying, right? And you have to multiply everything in the parentheses, so you do A times B first, and then A times C, and then add them together, okay? These two, commutative and associative, we use those a lot, but we don't usually say we're using them, right? So, for example, what's 3 times 5? 15. What's 5 times 3? 15. Does the answer change when you change the order with multiplication? No. What about 3 plus 5 and 5 plus 3? Are those the same answer as well? Yes, because addition and multiplication are both commutative. Okay, so commutative means if you change the order in which you do the math, the answer stays the same. It doesn't change anything. Subtraction is not commutative because if you do 5 minus 3 and 5 or 3 minus 5, you get 2 different answers, right? So that's what commutative is. Associative, if you notice with this, there is no order change. A, B, C, A, B, C, A, B, C, A, B, C, right? But what they're doing is they're telling us which ones we should do first. Because remember, parentheses, we always do those things in parentheses first, right? PEMDAS says always do parentheses first. So over here on this side, what would we add together first? What does this say to do first? Yeah, and which ones would we add together first together here? A and B, right? But what about over here? What would we do first? B and C first, right? So they're changing the grouping, right? But they're not changing the order. They're all still in the same order. Does that make sense? So that's the associative. Same thing here. We're going to do A and B multiplied together first. And here we do B and C multiplied together first. But it's still A times B times C. A times B times C. Okay? And then you know the distributive property. An identity is something that you do to something and it doesn't change. So, for example, 0 is the additive identity because what's 70 plus 0? 70. What's 5 plus 0? 5. What's 7 plus 0? 7, right? So anytime you add 0 to a number, does it change that number? No. That's why it's an additive identity because it doesn't change the number. Multiplication, it's a different identity because if you multiply something by 0, it becomes 0, right? But if you multiply by 1, nothing changes, right? 9 times 1 is 9. 27 times 1 is 27. 100 times 1 is 100, right? So those are the identities in each type. And then inverses are two things that when you combine them, you get the identity. So in addition and subtraction, those are positive and negative numbers. So things that cancel, right? That's what inverses are. So 3 plus negative 3, those cancel and become 0. In fractions, it's 3 and 1/3. Are opposites, right? 3 and dividing by 3. Those are inverses of each other. So they cancel and give you the identity. Okay, so you do need to be able to recognize those for the quiz. Okay, so we're going to practice 2 things using these properties. And we're going to practice simplifying and we're going to practice solving. So we'll start with simplifying. When you look at this, I think there's something you know you already want to do. What property do you want to use right away on this problem? Distributive property, right? You see the 6 in front and the negative 10 in front. So we're going to distribute first here. And remember, you're multiplying when you distribute. So we'll do 6 times 2x squared. 6 times 2 is 12, so that will be 12x squared. And then we'll do 6 times 4x. 6 times 4 is 24, so we'll have 24x. And then we'll also have to distribute the negative 10, but you got to remember to take that negative with the 10. Okay, so it's not just going to be 10, it's going to be negative 10. So we're going to do negative 10 times 4x squared. Negative 10 times 4 is negative 40, so that'll be negative 40x squared. And negative 10 times negative 3 will be positive 30. So that's where you really have to be careful to make sure you take the negative with the 10, because negative 10 times negative 3 will be positive 30x. Any questions about the multiplication that I just did with the x's or anything? So now, from here, is there any more math that I can do? No, you're fine. Go ahead.
Like two squares go together and then not.
Yep. Yeah.
I'm sorry, my brain.
I know, dude. I feel you. My brain does it every day. Yes, there's definitely some things we can put together, right? There's fancy math word, combine like terms, right? There's things that we can add together. Can I add these two terms together? Are those like terms? No. This one has an x and this one has an x squared, so those cannot combine, right? But can the 30x and the 24x combine? Yes, those are like terms. So we can combine these. When we're combining like terms, we're just putting them together as they are. So positive 24x plus 30x, combining them as they are, that will give you 54x. The x doesn't change because they're already x terms, so they're combining to be another x term. And then we can also add together the 12x squared and the negative 40x squared. And again, we're just combining them as they are, so it'll be a positive 12 and a negative 40 combining. So you can do 12 plus negative 40, you can do 12 minus 40, but you're just combining them the way that they are, so that will be negative 28x squared. Can I combine these two terms together? One's an x squared and one's an x term. So those are not like terms, so I can't combine those. So is there anything else I can do? That's it. That's been simplified now, okay? So simplifying is getting it down as simplified as it can be, basically doing as much math as you can. So first we distributed. We used the distributive property. Technically from here to here, we use the associative property because the order told us to add these two together first, but we changed the order. We added these two together first and then these two. So we regrouped them. So we technically use the associative property when we regrouped them, okay? Any questions about how we got there? So this is the final answer on that one. Okay, so that's simplifying. This problem over here has a different direction. What's the direction on this problem? Solve. What about this is different from that problem? There's an equal sign, right? And so we're going to get down to one number. We're going to solve for x, right? We're going to get x by itself, and it should equal something, right? So this has an equal sign, which is why we're solving, okay? Your first step with solving, though, before you solve anything, you're going to simplify both sides of the equation. So we're going to practice what we just did a second ago. By simplifying both sides of the equation. So first you'll start with simplifying like we just did there on both sides, then we'll start solving after that. Solve for x. So first, let's look at the right side of the equation, this guy over here. Can I add those two terms together? The negative 8 and the 3x, can I add those together? So is there any simplifying I can do over here on this side? No. But what about on this side? Can I simplify anything on this side? Yeah, what like terms can I put together? 5x and 3x. And when you're simplifying on one side of the equation, you're just combining them as they are, right? So 5x plus 3x will be 8x. And you still have your plus 7. And now there's nothing else I can do to this side, so both sides have been simplified, and that's when I can start solving for x, okay? Some of you have already started solving for x. Great. If you haven't, I want you to write down what you think just the first step would be, because everybody does these differently, and you can do them lots of different ways. So at least just write down what you think you would do next. Whose first step was to add 8 to both sides? Raise your hand if you added 8 to both sides. Anyone do that? Okay. I'll get to that one. All right, so one option is you could add 8 to both sides. Why am I allowed to add 8? What makes me add 8? Yeah, we want, like, your goal was to try and get over there with that, right? But we want to add because this is a -8, right? If we're going to move it to the other side or cancel it out, we want to do the opposite, right? So when you're solving and moving stuff to the other side, that's when you start doing the opposite. So that would be a valid first step. You could add 8 to both sides of the equation. Did anyone subtract 7 from both sides the first time? Anyone? No? Anyone subtract 3x from both sides the first time? Couple? Okay, that's my personal preference. That's what I would do first, because when I have x's on both sides, I'd like to get them together first, and then I'll worry about the numbers afterwards. You could subtract 8x from both sides, but I always like to move the smaller number just so you don't end up with any negatives, okay? So that would be my personal first step. You do not have to go back and do it this way unless you don't know what to do. We're going to subtract 3x from both sides. The whole point of that is that this will make this 3x go away, right? And so you're just left with -8 on this side. And then 8x minus 3x will be 5x plus 7.
Now we're just from the beginning, just add 8, subtract 3x.
From this one right here?
From the start.
From all the way up here? You can, but then you're going to have a 0 on the other side. Did you leave a 0 on the other side? Because that would tend to be what causes issues. Is people, if you added 8 and subtracted 3. Well, I guess, did you subtract this 3x or did you subtract this one? This one. So the only problem with that is that if you add 8 and you subtract your x, this is going to be a big old 0 over here. So if you didn't leave that there, it might mess you up later. So you can see how it worked out when you get down to the answer and see if it worked, and I can come look at it if not. So then from here, we need to get rid of the 5, we need to get rid of the 7 because we want x by itself. Which one should I do first? What should I do next? Subtract 7. I want to subtract 7 first. I can't divide by 5 first, okay? Because you want to do the opposite of PEMDAS, right? So we want to get rid of the 7 first. This is 5 times x right here. 5 times x, so eventually we will divide by 5, but you can't do that at the beginning. You got to get rid of the 7 first. So you're going to subtract 7 next from both sides. That'll make this 7 go away. And you'll get -15. And then over this side, you'll have 5x. And then because this is 5 times x, what's the opposite of multiplying? What am I going to do to get rid of that 5? Divide, right? Because that's the opposite of multiplying. So you should end up with x equals -3. Any questions on that? If you did it in a different order, it's all right as long as you got x equals -3 and you didn't make any illegal math moves. Any questions? All right, we're going to do one more solve together. And then we'll do one weird kind of problem before you try to practice them on your own. So this one here, we're solving. That makes sense because there's an equal sign, right? Whenever there's an equal sign, your goal is to solve for x. But first, you're going to simplify both sides. Then you're going to start solving. So first we'll simplify both sides and solve for x. The right-hand side just has a 35 on it, so there's not really much you're going to do over here. But what property will I use over here with all these parentheses? Distributive. So go ahead and do that first step. Do the distributive property on your own. And then I'll write down what it should look like so you can make sure you have it correct. So you should be doing -3 times 3x, which will give you -9x. -3 times 15, which will give you -45. And then here, you do need to distribute the negative. So you can either just distribute the negative, that's fine. If it helps you, you can also put a little invisible -1 here, and you can distribute the -1. -1 times 10 should be -10, and -1 times x would be -x. And then we have equals 35. So make sure you had both of these negatives here. This is usually the one people forget, is this one right here. Because you got to distribute that negative. Then you want to keep simplifying until both sides are simplified. Is there anything I can do over here? Can I combine anything over here? On this side, is there stuff to combine? 10 and the 45 and the 9 and the x, right, are like terms. So go ahead and combine those on your own. If you need to use a calculator, no shame, that's fine. You can combine the -9x and the -x, and you can combine the -45 and the -10. So you should get -10x when you combine these two. You're not going to add x to this -9x. You only do that when you're solving for x and trying to move it to the other side. Okay, when you're simplifying, you're just putting them together as is. So -9 plus -1, if it's helpful for you to think about a -1 in front of that x. And then same thing here with the -45 and the -10. It should be -55 when you combine them. Now that everything's simplified, that's when you can start doing the opposite to get x by itself, right? We need to get rid of the -10 and the -55. So first we'll add 55 to move it to the other side and cancel it out. So when you start solving and moving things to the other side, that's when you start doing the opposite. So you should add a -10x is equal to 90. And then this is -10 times x, so the opposite of that is dividing. And you get x equals -9. Any questions on this problem? Okay, so for these next two problems, these are a little weird because they have more letters, right? This one only had one letter, X. Now we have P, L, and W, okay? These follow the same rules, though. Nothing changes about the rules. We're just solving for a letter, so our answers are going to have a lot of letters in them, okay? So I'm just going to rewrite this first one down here, so I have a little more space. So my formula is P is equal to 2L plus 2W. And we're solving for L. So we want to get L by itself. Just like we solved up here for X, and we got X by itself, down here we want to solve for L and get L by itself. So when we were up here at this step in the equation, and we wanted to get X by itself, did we divide by -10 first, or did we add 55 first? We added 55, right? We got rid of the thing that was furthest away. So here, to get L by itself, you're going to have to get rid of the 2 and the 2W, right? But which one do we want to get rid of first? The 2W, Okay, not this. This problem you can divide by the 2 first if you want, and you can solve it. But some problems that won't be possible. But because this is also divisible by 2, if you divide that by 2, that's fine. Okay. So usually we want to get rid of this thing first because we would have to divide everything by 2, including that guy. Which this one, that's not bad because there's a 2 there. Okay. So if I want to get rid of this 2w, we're adding 2w. What would I do to move it to the other side? I would subtract it. So I'm going to subtract 2w from both sides to get rid of that. That would cancel it out over there. But this is where it's a little weird because when I go to subtract 2w over here, can I do p minus 2w? No, those are not alike at all. But that's okay. We're just going to write it down. If we can't do it, just write it down then. So p minus 2w. We can't do that math. That's fine. Just leave it like that. And then on the right-hand side, you have a 2L left. What's happening between the 2 and the L? What kind of math? So how am I going to get rid of that 2 then? Just divide. That's it, right? Just to get rid of it, you're just going to divide. Divide this whole side over here by 2, though. Okay? Everything on that side. Everything has to be divided by 2. So then you'll get L on this side, and you can just leave your answer like this, p minus 2w, all divided by 2. That's one way you'll see the answer. Or you can divide each part by 2 individually. So if you do 2 divided by p, you'll have p divided by 2. And then if you do 2 divided by 2w, you'll just get w. So both of those are 2 ways you might see the answer, either leaving it all over 2 or actually dividing each part by 2. So because I have the minus here, yes, this is, you could write that as minus 1w. I just left it, like usually it'll be an invisible one. Does that make sense? But if you wanted to leave it in there, that's fine. Any questions on number 4?
So for this one, do we have to like simplify it?
Either one of these would be fine. If it's like a Schoology assignment, you might see the answer either way. You know what I mean? So that's why I want you to kind of be aware that they're the same. If it was on paper, I would take either answer. Any other questions on 4? All right, 5 is probably the trickiest one, so we'll do this one together. This one we're solving for p. I'm just going to rewrite the equation. But what's weird about this equation?
PRT?
Yeah, there's a PRT and a P. There's multiple P's, right? So this one's a little tricky. So the first thing we want to do is not have multiple P's. And we can't add these together, right? They're not like terms, okay? This one doesn't have an RT in it. So what we're going to do is we're going to factor this P out. So we're going to put P parentheses. We're going to factor it out or divide it out. When I do P divided by P, I'll get 1. There's nothing else left here. There was just a P there. So when I divide it out, I'll get 1. And then here, when I take out the P, there will be an RT because I took the P out. And you still have your equals A.
Where's the 1 from again?
Because we're factoring it out, which I'll show you right now too. If that feels a little confusing, just think about what we did. We undid the distributing, right? So if we distribute right now and undo what we just did, we would do P times 1, which would be P, right? And then we would do P times RT, which would be PRT, right? And now we're trying to get P by itself, right? All of this is what's happening between the P and all of this, because it's sitting in front of their multiplication, right? When it's sitting in front of the parentheses. So all of this is being multiplied by P. So guess what? I can move all of that to the other side in one step. By doing what? Just dividing it, right? If it's all being multiplied, that's what that parentheses mean, right? If it's all being multiplied by P, then I can move it to the other side just by dividing all of this. That will cancel it out. And you'll have A divided by 1 plus RT. So this one is confusing, but it actually has fewer steps. And that's all that you will leave your answer as.